In this video, let me try to find out if a set of vectors is linearly dependent. For example, let's look at these three vectors. The vector 1, 1, 1, vector 0, 1, negative 1, and the vector 2, 5, negative 1. So suppose that I have these three vectors and I want to find if v1, v2, and v3 are linearly dependent. I want to find out whether or not this is true. In order to do this, really what we're trying to look for is if there is a secular equation like this, which has non-trivial solutions. If this has non-trivial solutions, that means that the set of vectors are linearly dependent. But if only there is a trivial solution, that means that they're linearly independent. So trivial solutions imply that these are linearly independent, but non-trivial solutions imply that these are linearly dependent. Remember that non-trivial means that I have C1, C2, and C3 different from 0. A trivial solution is just the solution 0, 0, 0. So what we have in this case is that we can write down the matrix coefficient for these vectors. So I can write down the first vector, the second vector, and the third vector. And my strategy is to find out the reduced echelon form. And depending on this reduced echelon form, I'll figure out if there is only one solution or an infinite number of solutions. Notice that trivial solutions will always work. That means that C1 equals 0, C2 equals 0, and C3 equals 0. This is always a solution of this vector equation. So really the question is if I have non-trivial solutions or not. In order to do this, let me do the following thing. Let me try row reducing this matrix. So I'm going to replace the second row by the second row minus the first row. And I'll do something similar for the last row. So I'll replace the third row by the third row minus the first row. That way I can just leave this top one as my only pivot for that column. So if I do this, then I will get the first row to be the same. My second row would be 0, 1, and then 5 minus 2, that is 3. And then my last row, that would be 0. This will be negative 1. And then negative 1 minus 2, that will give me negative 3. So you can probably see what else can I do in order to keep doing with this. Now I want to get rid of this guy right here, because I have already two of my pivots. I have these two guys to be my pivots. And remember, whenever we are reducing in echelon form, the pivots have to be equal to 1. So we can replace the third row by the third row plus the second row. And that will help me clear those things out. So if we do that, first row will stay the same, the second row will stay the same, and then the third row would be actually just zeros. It will be 0, 0, 0. And this is already the reduced echelon form. Remember that in order to check if something is on reduced echelon form, we have to have all of our pivots to be equal to 1. And in those pivot columns, everything else should be a 0. So those two conditions are met in here. We have that every pivot is 0. Sorry, it's equal to 1. And everything else that is not a pivot is equal to 0. So those two conditions are met. That means that this is the reduced echelon form for that matrix, and this is unique. So no matter what you use, your reduced echelon form should be the same. Now in this case, notice that we have the last row to be actually just a row of zeros. In other words, notice that we don't have a pivot in the last column. This is a free column, so to speak, because I don't have a pivot. I can think about a pivot as something fixed. This means that I can relate that last column as a free variable, which tells me that I actually have an infinite number of solutions. This is going to be a free variable. Every time that I have a row of zeros, this implies that I have an infinite number of solutions. And this really means that I have non-trivial solutions. Since I have non-trivial solutions, this implies that my original set of vectors actually is linearly dependent. So I have that v1, v2, and v3 are linearly dependent. So to answer the first question, with my original set of vectors, I have that these are linearly dependent because basically I have this row of zeros. That is my way to check it.